Hello, I'm Leonardo Freire, and this is my 212 submission for graphics. So, first of all, start off talking about the track. The track is actually defined by the shape of the asteroids, which have colliders. So, here we can see two straight line segments and two curved segments. Okay, so the two segments, which are straight lines, are actually made using for loops and then increasing the position by a set amount for every single time. The curved ones, the inner curve is made by having a smaller radius and then using half the circle, and then the outer circle is made using a bigger radius and also half the circle, and then on the other side you just do the equation but you stop it at a different time. Covering the mark scheme also mentions fully steerable. Here you can see you can move forwards, you can move backwards, you can move left, and you can move right. So now I'll be showing off the various types of animations in the scene. Okay, so here you can see that the asteroids are moving. They're slowly rotating, they're all rotating in the same direction. So how this is done. So a value is set in update, which keeps on adding to the current rotation. But at the same time, there has to be a delay. So it keeps on adding to the current rotation via a transform, and it's divided by a number delay so that it doesn't spin too quickly. And eventually it'll reset every set amount of frames in order to keep rotating. And in the background you can see that there's also a moving planet and another planet next to it, and there's a dead looking planet which is no longer moving. We can see this throughout the scene, and we can see here that the planets also can have a variation on their rotation. So this scene isn't static, it's more dynamic. And here you can see a different type of motion where it's an up and down motion on this asteroid. So this is done almost the same way. It keeps on adding a set amount in the update, so you can keep moving forward. Because the translate works by adding on to the current position. So it needs to have that smooth transition. And then instead of actually resetting back, it will count up to a certain amount and then it will count down. And that is how you get that effect. Next I'll be talking about the different cameras in the game. So here we can see our default camera. It's a pretty standard camera, gets the job done. But also I've added in a top down, so you can see here it's now become top down, and a further zoomed out top down so you can get a better view of the track. The way this was done was just simply to add on to the GL look at, and then the different values that the camera is looking at, you just add onto these values every single time the spacebar is pressed. Now I'll talk about the lighting. The first type of lighting I'll talk about is ambient lighting. So what is ambient lighting? Ambient lighting is when light is reflected onto all other objects. It's scattered around and it gives a color to the shadow that we see. So here I've set the ambient light to give off a dark kind of orange shadow. This is because I wanted the player to know that the sun is emitting a lot of light, but it's also emitting a colored light to make it look more realistic. So how is this applied in OpenGL? From the code below you can see that we need a GL material FV. So then this goes on to specify the material property for the light calculations. We then have to indicate which face of the object the material is actually applied to, and then we pass through the values. The next type of lighting that I'll be talking about is the diffuse light. So what is diffuse light? Diffuse light is when a light hits a surface, the light rays scatter around and bounce, and this creates a lit part of the object. And the further out from the light you are, the less it's seen. So as an example, we can see here that light is hitting the asteroid directly, but then we can see a yellowish kind of tinge around the asteroids, especially in the moon. You can see it further out, which then becomes the darker kind of orange. And this is our diffuse lighting. So as mentioned before, you have the material which shows how it really interacts with the light. The next type of lighting I'll be talking about is specular lighting. This is when light rays bounce directly off the object from the light source into our eyes, essentially creating a reflection of the light source. So as we can see in the ship, you can see the specular lighting. It really highlights the object's curves and edges. So again, a material is applied to the ship. This material has to first be enabled through GL light, and then its parameters are set in GL light FV, and then the material specifies how it interacts with the light. I have now enabled a second moving light, so now there's moving light and there's multiple lights in the scene. As before, I showed off the specular light rotating in the torus of the spaceship. Now you can see that it no longer does that, but the back does, because there is a light attached to the front of the ship. So it's more consistent, but the back of the ship still can be changed. So I've created a gap in the track, because before we spoke about how the ambient light created a shadow at the back of the asteroids, and now, since we have another light, the shadow should be overridden. As you can see, it's now no longer darker because the ship's light is overriding the other ambient light in the scene, and you can see that this updates as we move along. So if we keep moving here, you can see that it becomes darker as we're going past it. So yeah, how does this work? Okay, so the light is being moved using the camera follow, and so this is updated every single frame, so then it can recalculate how the light interacts with the object. Next, I'll be talking about how textures are made. So first we need a means of getting the bitmap file, and I've been using the getBMP script. So essentially what this does is it takes in an RGB, it reads its information such as size or color, and it creates a space in memory where it can be used and applied within the scene. So then, specifically for OpenGL, we then have to basically say that we want to generate textures. We want to load external textures that we've actually been put in from the get BMP file. So then we can give it parameters. For example, if we want a repeating texture, or we want it to clamp, or any of the other effects, we have to specify this. So then we need to then enable texture 2D, and then we need to specify a quadric. The reason why we need a quadric is because we can't use a glut solid sphere, because this will not work with textures, but glue sphere will work with textures. Now we'll be talking about the skybox. The way it's done is very similar to adding textures onto the other objects with a slight variation. The first variation comes with loading each side of the skybox. We have different images for the different sides of the skybox, so there's 6 sides in total, so we create an array of bitmap files. So then we can load these files, but in the texture parameters also, we want to make sure that it repeats, because the sides of the skybox are very large, so we want to make sure that we can repeat the texture so it doesn't look stretched out. I've used the alternate method of binding a GL text coordinate below to define every single side of the skybox. All we have to do is just have some set numbers where we make them minus or make them not minus.